Yes, so let us come back to one more question. We have done almost two questions based on the structure of function groups. We have picked up reasoning question like inductive effect plus I effect, no, minus I effect plus R effect, and we also told double bonds shorter than single bond. Let us come back to one more question. Here, the bond angle in alcohols is slightly less than 109 degree 28 minutes. That is the tetrahedral angle in alcohols. Why? Basically, when I see the structure of alcohols, it is like this, right? So when we see the structure, it's basically, or it resembles tetrahedral structure. Now they are asking us, why is this less? It should be 109. Why is this less? Simple reason, nothing. Now when I speak about this highly electronegative oxygen atom, what are you finding here? You have, these are your bond pairs, bond pairs, bond pairs, bond pairs. They are lone pairs. So what? They are lone pairs on both the sides. Now because of the lone pairs, so what reason will I write? Because of lone pairs on oxygen. So lone pairs on oxygen, you are finding lone pairs on oxygen both the sides because of this lone pair repulsion. So this and this will start repelling, yeah. So LP repulsions. So what happens to LP repulsions? It will try to drag the bond towards this, like, you know, it's trying to drag. This is first of all electronegative in nature, and because of the repulsions further, it will, instead of this bond expanding out, it will try to pull the bond closer, right? LP repulsions, bond angle decreases from 109 degree 28 minutes to 108.9 degree. We very well know LP repulsions are stronger than BP repulsions stronger than BP repulsions, right? This is your main reason. If you just mention this and show them the concept, the answer is complete. Let us read one more. Why is the bond angle in ether slightly greater than tetrahedral? Here they said it is lesser. Here they are saying it is greater. Here 109 degree less than that, but it is 111.7. Now what are you finding? What difference are you finding? Here you have lone pair. Here also you have lone pair. Here you have a smaller hydrogen atom with 3 hydrogen atoms, 1 carbon. But here what's happening? Only difference in ethers is, apart from the lone pairs, you have 2 electron donating groups. Alkyl groups are always electron donating. So here there are 2 electron donating groups. They keep on donating electrons towards this. When they are donating electrons towards it, there is a lot of electron cloud created, yeah. So now I'll write, here I spoke in terms of oxygen. Here I'm going to speak in terms for ethers. You're going to sponsor, this is your ether. So in ethers you're going to speak due to repulsions between 2 bulkier, due to repulsions between 2 alkyl groups. Repulsion between 2 alkyl groups, your bond angle increases from 109 degree to 11.7 degree. So 109.28, okay, specific, yes, 28. So here it was due to difference in electronegativity and your lone pairs. Here this is basically due to your alkyl group. Please note it. Now I'll be starting with the preparations of alcohols. I already given the index for the preparations of alcohols. Let us once again write what are the subtopics for preparations of alcohols. So when I speak about alcohols, I can prepare alcohols from alkenes. I can prepare alcohols from alkenes. There is one mechanism here, very important mechanism. I'll tell you how to remember that. And this particular mechanism is called acid catalyzed hydration. Okay, acid catalyzed hydration is a conversion of alkanes to alcohols in the presence of an acid. Okay, next would be your hydroboration. I'll write this preparations. Okay. hydroboration oxidation reaction. Hydroboration oxidation reactions. The next type of reaction is preparation from carbonyl compounds. Carbonyl compounds, I'll be picking up aldehydes. I'll be preparing this one from aldehydes. I'll be preparing from ketones. I'll be preparing from acetyl chlorides. I'll be preparing from esters. Yes. After this, I'll be also preparing alkenes from alcohols from Grignard's reagent. Let us see this reaction. First, I'm going to pick up this. So write the heading: preparations in block acid catalyzed hydration of alkenes. Right. So this is your heading. They'll ask you the mechanism also. Let us see. Basically, we have already studied whenever I have an alkene with me, alkene has a double bond. Because of this, it undergoes addition reactions. And one more thing which I have studied is alkenes undergo Markovnikov addition. In that addition only, Markovnikov addition as well as anti-Markovnikov addition in the presence of peroxide. So let me use that and write. Suppose if I have an example, a smaller alkene, pick up anything, ethene, right? Now, fine. Why did I pick up this? This is a symmetrical alkene, because when I take this and see, when I hold my hand, on either side I have equal number of carbon atoms. Suppose if I add HOH to this, fine, simple, H and OH minus. H goes and adds here and OH comes and adds here. So I get C, this double bond is broken, single bond C, H, OH, 1, 2, 3, 4, 1, 2, 3, 4, simple. Suppose if I pick up one unsymmetrical alkene. Now this is a symmetrical alkene. Now pick up one unsymmetrical alkene. Now this is unsymmetrical. Why? If I hold this here, on the either side of the double bond, here you have 2 carbons, here you have 1 carbon. So it is unsymmetrical alkene. Now to this unsymmetrical alkene, if I add H plus, no H minus. Yes, we very well know, according in unsymmetrical alkene, if you have an unsymmetrical alkene, it's going to follow Markovnikov addition, Mark addition. Yes, unsymmetrical alkene, in the absence of, there is no peroxide here. So the negative, so I'll write this H3, H. Now, according to Markovnikov addition, the negative part of the addendum adds to the carbon having lesser number of hydrogens. Correct? The negative adds to the carbon having lesser number, means this is 3, this is 1, this is 2. I have to add OH here and H here. So for that you have to break this bond. So how is this looking? C, H3, single bond, C. Now there is already one H, right? Write that H on the top. This OH minus, so dash. So CH2. So this H has added here, so this becomes CH3. Let me count. 3 plus 1, 4. This carbon has 1, 2, 3, 4 bonds, and this has 4 bonds. Right, done. So it's going to form which type of this one? This is, if an alcohol, if OH forms here, it is called primary. If it forms here, because this carbon has only 1 hydrogen, it forms secondary alcohol. Correct? Secondary alcohol. That is what is the example given. So any symmetrical, you can pick up any symmetrical, any unsymmetrical. So now this particular your board wants you to learn this particular reaction using an acid, right? You have to show, they'll ask you acid catalyzed hydration of alkene. Here I directly studied Markovnikov addition, not a problem, but here I have to show using an acid catalyzed reaction and finally prepare alcohol. Fine, let us see that, note it and come back with the mechanism. Yes, so let us do the mechanism. Acid catalyzed hydration. Hydration means addition of water. Don't write addition of hydrogen. Hydration of alkenes. Which alkenes? We're going to pick up symmetrical alkenes. Now I'm going to pick up symmetrical alkenes. Let us make this fine. So as I have written already in the reaction, C double bond C, this is my symmetrical alkene. I am going to add HOH, but this should occur, this is a reversible reaction in the presence of an acid. So instead of H2SO4, I'll be writing H plus, not a problem, right? H2SO4, instead of writing this, just write acidic medium. So both are same, this or this. So this, the product which you get is, this is going to break here, OH comes and adds here. I get C, single bond, C and H and OH. I have to show this in the form of mechanism. Now, let us see the steps. First important step 1. First, important thing is, always remember, when I write H plus, right? Now, H plus can't exist like that in water, right? Fine, it's electron deficient H plus. So it will not exist as this form in water. So what it does, it immediately combines with water molecule. Right, when this H plus ion from the acid, when it is broken into H plus and the other nucleophile, it will immediately combine with water forming H3O plus ion. Now, this electrophile, now this is an electrophile, correct? Yes, plus charge. Now this electrophile will go and attack your alkene. So the first step, what should I write? Step 1, protonation of alkene. What am I doing? I am going to add proton to this, proton to alkene. Protonation of alkene is addition of proton. So you can also write like this, addition of proton, H plus. Fine. So take this alkene, C, I write a bit above, C double bond C. Right. Now you are H3O plus, right? Protonation, you pick up this, right? H3O plus. So how am I writing H3O plus? H O, H and O. Isn't it? H3O plus. Now 1, 2, 3, 4, 5, 6, 7, 8. Correct? Now, when there is a cleavage of the bond. When this is cleaving, what happens? This particular bond is broken and it is shared by H. And immediately this bond, whatever is there, it shifts to this. Now what do we get? We get, now this bond is broken, form a bond with hydrogen, C, these two are here, now this H comes in, attaches, second, now because this has lost a part of the bond, this becomes deficient and becomes carbocation. Right, and what else do we have? We have water molecule again coming. So that is the reason, what did I do? I added H plus here. That's why it is protonation of alkene, addition of proton. I am adding protonation of alkene, addition of proton. This is called your carbocation. Done. So second step. In your second step, you have to remember, yes. To this, now this has become electron deficient. There should be something to donate electrons. That means something should have a lone pair of electrons to donate to this carbocation. So now, which has lone pair? We will write nucleophilic attack of water on carbocation. Basically, we have this carbocation. Take this carbocation with H, yeah, and after that you're going to pick this carbocation, you're going to add water to this H, O, H, right? Water 1, 2, 3, 4, 5, 6, 7, 8. Fine. Now this has lone pair of electrons here, so this is going to donate electrons. This will come and attach to this carbon. How does this look now? C, this is your H. And your C, fine, this whole thing, now I am going to attach this whole group to this. So let me write this here and start from your electronegative atom, oxygen, hydrogen here, 1, 2, right, this is 1, 2, 3, 4. You have your OH, fine. So this is donated because you have carbocation, fine. Now after donating, what happened? This has shared a pair of electrons to this, so this becomes plus. Remember that. Yeah, because earlier this was plus carbocation to satisfy this, a lone pair of electron from oxygen has shared. Now oxygen, because it has shared its lone pair of electron, you get this forms the carbocation now. Now I'm going to pick this up and I'm going to write step 3. Now in step 3 what happens? I am gradually preparing alcohol, isn't it? Now what are we going to write? We will just write, now protonation I did, nucleophilic attack we did. Now I have to take out that OH. I just need this. So what do I write? Here I did protonation. Now you will write deprotonation. Deprotonation of alcohol. So now you will deprotonate, means you will take out. So how will I take out that deprotonation? Pick this whole thing here. Carbon, you have your hydrogen here and you have your carbon. Along with that you have an electrophile, that is O plus. Add one more water molecule to this, H2O. So now what happens? A bond or part of this H2O comes out with this H, and this bond because shifts. Now when this bond shifts here, how does this look? Yes, carbon with H. Done. Now this is single bond. Now this is C, right? You have both the sides be iron, right? So CH2OH. Fine. What type? Let me count. 1, 2, 3, 4. So indirectly, how does this look now? CH2, CH3, CH2OH. Isn't it this one? Same thing if I write this one. What do I get? CH2, CH3, 1, 2, 3, right? HH, CH2OH. Same thing, this is H and this is H. The same thing I have got. What did I get now? I have got primary alcohol. So please note the mechanism. Remember, protonation, nucleophilic attack, deprotonation. So before you go for your exam, just write 3 steps like this. Remember, protonation, nucleophilic attack, deprotonation, your answer will be complete. Very important mechanism, note it.